Hi, this is exercise 2B.1 for Year 12 students. Carries on from our work on functions. Last lesson we looked at functions and mappings and trying to work out the difference between them. And today we're going to look at something called domain and range. Now, you can see on this diagram here, the range is effectively the values that come out of a function. So on this picture, you can see it goes up to, I don't know, if I made up some numbers here, I'm going to say this is 10, this is 20, this is 30, this is 40. So completely made up, but you get the idea. You can see the range seems to be from about 12 up to, I don't know, it looks like 32. So we could quite easily say the range for this is between 12 and 32. So there you go. Seems to be allowed to be equal to it as well. I use y there. Some people instead of y would write f of x. You'll see both of those, and the function it's written as f of x. I probably should have written it. The domain is the numbers that go into the function. Now this function seems to start here and end here, and that allows us to use those values from x. So again, I'm going to do exactly the same thing. I'm going to pretend this is 1, 2, 3, 4, 5, etc. And you know, whatever they really are doesn't really matter right now. And you can see the x values, how far it goes across, seems to run from about, I don't know, I'm going to say that's 1.1 up to about 4.5. And again, it seems to be the case that they're allowed to equal it. And that's what we do. We're just saying what values we can put in or take out of a function. So we are often asked to find the largest possible domain. And very often it's actually all values, and of course we write all values. There's a posh way of writing it. This means all possible values. X belongs to the real numbers, and real numbers are all values that you can think of. So we basically assume, unless we've got a good reason to suggest otherwise, we basically assume for any function the largest possible domain of that function will be all numbers. Now there are some exceptions to this. For instance, I know that some functions end up dividing by 0, and we're not allowed to divide by 0. So look out for that. If you've got a function like this one here, my assumption initially is that x can be any number, but then I look here and think, oh, a bit, what value of x would make me have a division by 0? And you can see if 3 minus 5x was equal to 0, or I could say that another way, 3 equals 5x, or simplify a bit further. If x is 3/5, then I would end up getting a 0 on the bottom, and 3 divided by 0 I can't do, and therefore effectively I would say for that function, for the domain, x belongs to the real numbers, but x is not allowed to equal 3/5. And this is what you have to do. You kind of pick off numbers which aren't possible. Likewise, you're not allowed to square root negative numbers, so square rooting a negative is bad. And so again, you look at this function, f of x is the square root of 2x minus 5, and you think to yourself, hang on a bit, I'll do this down here. I'll say, if 2x minus 5 was less than 0, I couldn't do it. I couldn't square root it. So you go, 2x is less than 5, because the 5 moves over. X is less than 5 over 2. If I get any number less than 5 over 2, I will have a problem. So here the domain would be x belongs to the real numbers. But x had, because this is bad, so x has got to be greater than or equal to 5 over 2. It can be equal because you can square root 0. And the other one I would suggest you look out for is logarithms. And you can't logarithm, find the logs of negative numbers again. So you can only log positive numbers. So in the same way here, if x plus 4 was negative, I must just do it over here, if x plus 4 was negative, I'd have a problem. So when is that going to be a problem? You could say, you could set it equal to being positive, say, and that saves you having to turn it around at the end. So when is it positive? Well, it's only positive when x is greater than minus 4. So therefore the domain is x belongs to the real numbers. X is greater than minus 4. And that doing it that way round is actually strikes me as a better option. I perhaps should have done it here if I'd written greater than, or equal to. You're allowed to, that can be equal. That interestingly can't be. Greater than or equal to. And then they're the numbers you do want. So that's just look out for these then. So division by 0, square root in negatives, and find logarithms of only positive numbers. So here's an example of one such function. Notice it's asking me to find the largest possible domain. Because I could restrict the domain just to like 4 different numbers, but I'm not looking at that particularly. I want the largest possible. So as soon as I see this, I think, oh, a bit. If x equals 2, I'm going to be division by 0. So that I can't have that. So x can't equal 2. And if x was less than 3, no, less than minus 3. Let's do this the proper way around. I want this to be bigger than 0, because then, or equal to 0, because then I can square root it. So x is greater than or equal to minus 3. So I have now 2 rules for this function. There's 2 parts of it. Both can fail. So for me, I'm going to say, and notice the way it's sometimes written, x is such that x belongs to the real numbers, but x is greater than or equal to minus 3, and x is not equal to 2. You can write that in much simpler ways just by writing these last 2 things down. But it'd be interesting to see what I've got as my answer. What have I written as my answer? You can't barely see it. More or less what I've written. Yeah, just about make it out. I didn't bother with the curly brackets. I didn't bother with this bit, but that bit is what the answer says. So that's the largest possible domain of that function. In set notation, it can be written slightly differently. So just look out for this. This in set notation, we are meant to understand set notation. So this says, again, x belongs to the real numbers. It's a proper number. And notice the comma in between. X belongs to. Now this is basically saying it's from minus 3 up to 2. So it's any number from minus 3 up to 2. You imagine a number scale. It can equal this. That square bracket means this one's okay, but the 2 means it can't equal that. Or, do you remember this union? This means or, this union. It could be also in the interval from 2, well, up to infinity. You know, you're never going to get close to there. Again, it can't equal 2 because it's a curly bracket, not a square bracket. And it obviously can't equal infinity. You'll do well to find a number equal to infinity. So this is just an alternative way of writing it, which I want you to be aware of. What is the largest possible domain of this function? So again, remember what I said. I said logarithms cause us problems. Doesn't matter which type of log. It can't be 0 or negative. So, well, let's just say then 4 minus 2x has to be bigger than 0. 4 has to be bigger than 2x. Now I don't like particularly the 2x being on this side, so how about I switch it around, and when you switch it around that sign's going to change, and then x is less than 2. So my largest possible domain is x belongs to the real numbers, x is less than 2. X belongs to the real numbers, x is less than 2. In set notation, well, let's see if we can have a go at this. It's easy to get it wrong. X belongs to the real numbers. Now remember, it's all numbers, so I can basically say it's from minus infinity up to minus 2, and I think that's probably it. Yeah, there you go. Oh, I missed out the x belongs to bit. So set notation is only relatively recently been put back onto the syllabus, so I'm a bit dodgy, you have to forgive me. Domain and range then, just to clarify once again, the set of all possible inputs or x values, that is the domain. So this is what goes on left and right in a graph. Now it highlights basically if you sketch a graph or use a graphical calculator, then you can see what's going on much more clearly. And here it goes from there to there. The range is the y values. I want to highlight that to you several times. And I suppose we have started looking at these posh symbols. So this means the real numbers. So by real numbers, I mean, well, you can have -1, for instance. You can have 0, you can have a half, you can have 2.57, all numbers in between. So you have decimals, fractions, whole numbers, negatives. These are these are the numbers that you think are proper numbers. Whereas these are the integers, and therefore I can have -1, I can have 0, I can have 1, I can have 2, but I can't have fractions and I can't have decimals. So these are just whole numbers. So integers are with a z, proper numbers, real numbers, are going to. Largest possible domain then, a couple of questions really. Normally I would give you these to do in class, but I'll do them quickly now. Again, you might find this actually, if you was to sketch it, you'd be able to do it quite quickly, but because it's a quadratic, I'm going to complete the square. I'm going to write x plus 2 all squared. Remember, you take away the square of the 2. 2 squared is 4. Obviously, you have to half the 4 to get the 2. That was the trick. Don't forget the minus 1. So this is x plus 2 all squared minus 5. Now, I know then that this tells me something. You see here, that's minus 2. Kind of doesn't really matter that much. The bit that matters is the fact that it goes down to minus 5. That's the curve. And so therefore that tells me about the domain and the range. The domain, you'll notice, is all numbers, and if this carries on in both directions forever and ever. So the domain for me is all numbers. X belongs to the real numbers. The range, remember how we wrote that? I said I should probably have written something about f of x. Sometimes I write y. But that doesn't ever go below minus 5. It's always up from minus 5. So it's greater than or equal to minus 5. And it can equal minus 5. So that's what I've written. X is real. Y is real. And notice here I've switched to y's. There you go. After I've tried to be good. But basically y is real and y belongs to greater than or equal to minus 5. And the second one, the largest possible domain and the range for this function. But again, I know I'm not allowed to do negatives. So x squared minus 16 is greater than or equal to 0. X is greater. Oh, you've got to be a bit careful with inequalities. There's 4 and there's also a minus 4. Now I think it's this. Let's put equals them as well. I think it's that, but you'll probably see this on the graph better. This is actually the graph. That's where minus 4 is, and that's where 4 is, and it's a weird. I've not seen a graph quite as horrid as that before. But you can see it's basically a square root graph, but starting at 4. But because it can be plus or minus, doesn't say which one it is. It could, it's over here as well. So, okay, that's fair enough. Well, let's talk about the domain now. You can see clearly the domain. Well, it's all numbers bigger than 4 and all numbers less than 4. How do we write that? We say x belongs to real numbers. X is less than or equal to minus 4, or x is greater than or equal to 4. What about the, so this was the domain. And what about the range? Well, on the range front, you can see it never goes below there. There's no negatives. It starts at 0 and it goes upwards. So I'm just going to stick with my f of x. F of x, oops, is greater than or equal to 0. So let's see what I wrote last time. Exactly the same, apart from I've been a bit more careful about writing things like this. Y belongs to the real numbers. I wrote y rather than f of x, but you can write either. I wouldn't worry about that at all. And so that's basically it. So I want you to do some of exercise 2B. Notice there's another PowerPoint coming. That's because from memory there was a lot to do. Now you can crack on with that, but I'm going to do more in a second exercise called exercise 2B.1. And so don't feel obliged to do them all. So hopefully that was okay, and you'll now be able to do the questions. Best of luck.